Well, lycopodium powder is pollen from trees, actually. And as you can see, that yellow on top, that's lycopodium powder. And I'm going to have someone come around with this. If you stick your finger in it, pull it out, it will have a little bit of lycopodium on it, but your finger will not be wet. It's pretty cool, actually. Okay, so what I'm going to do is light it on fire. So lycopodium doesn't light very well on fire, so I have to use a gas source. And okay, can everybody see how it's like a blue color? Well, I'm going to change that into a much bigger flame and a different color. And we're just going to start off with a little one. Whoa! Sorry. Okay, now if you like that, why don't we try making a little bigger flame? So you guys in the front row, watch out.
Especially John.
You ready?
Whoa! That's cool.
And what happens is the lycopodium actually can't light on fire if you have a big pile of it. But when you mix it with oxygen in the air and you blow it into a fine mist, it turns into a huge flame.
Can any of you read this?
No.
No?
It's invisible ink.
Close. It's a kind of invisible ink, but it's chemistry. Just watch. It'll work. Maybe. Spray. Cool. Wow. It appeared like this because I sprayed it with a special chemical, which it's Windex, but it has certain properties that make the stuff I use to write the message show up. Now, the stuff I used to write the message was called phenolphthalein, which we abbreviate as PPT because that's a big word. It's kind of hard to say. And when it comes in contact with stuff like Windex or things with properties like Windex, it turns this really pretty pink color.
4th of July is my favorite holiday, and on 4th of July, what do you guys like to do?
Fireworks.
Of course, watch fireworks. And so, my favorite fireworks of all, I like the really big ones, but my favorite ones of all are just the simple little sparklers. So today I'm going to show you an experiment that's very similar to a sparkler, except a little bit more dangerous. And what I'm going to do is take a strip of magnesium and burn it, and it will produce a similar thing to a sparkler. But you want to be careful because the light that is created is very, very bright. So do not look directly into the light because it could permanently damage your eyes if you looked in it for long enough. Okay, are you ready?
Whoa. Look away.
You guys can see?
How many of you think that you could crush one of these cans? And now, how many of you think that you could do it without using your hands or your feet? Okay, well, I'm going to show you the way to do it with water. So first, I need to put I have ice cubes in this little bucket. water in the bottom of one of these cans.
Oh.
And
Watch. Go ahead and watch.
Whoa.
okay. Now,
What?
do you have a question? Do you have a question?
The can was I think the can was heated.
Okay, you're right. What I did
Watch.
I put water in the can, and then I heated the water until it starts to boil. And if you look closely, you can see steam coming out of the top. So once there's steam, then if you turn it over and put it into the cool water, then the can, there's less pressure on the inside and more on the outside, so the can crushes inward. And I can do another one for you guys.
Watch. It goes fast.
Okay, ready? And then all the water gets sucked up into the can. That's why. I have one more for you. Okay, ready?
Like really cool.
So how many of you fourth graders think that you're faster than me? You think you can be faster than me? All right, let's test this theory. Okay. All right, so here I have 3 cups, nothing in them. As you can see, nothing in them. All right, I'm gonna take some water and I'm gonna put it in the middle one. Just a little bit. All right, now I'm gonna mix them up and you guys have to tell me which one the water is in, okay? Okay, in the middle one. So watch carefully, watch closely. See if you can do it. Okay. All right. Oh, everyone thinks they know?
Yeah.
Okay, how about in the black shirt? Which one is it? This one? Who thinks it's this one? Everyone? You think it's this one?
No.
You sure?
No.
It's not this one? You think it's the middle one?
No.
It's the last one?
No, the water.
Where's the water?
Evaporated because you're moving something.
It evaporated? I don't think I can move that fast.
You said you were fast.
Okay, ready? Okay, I'm gonna do this again. Watch very carefully. I'm pouring water in. I'm not trying to trick you. Pouring the water in.
Watch it, Hunter. Watch.
All right, let's try this again. Very carefully. This one, right here, in the middle. This one. All right, here goes. Where's it at? All right, down the front row of the block.
That one?
This one right here? Who thinks it's this one? This one? Nobody thinks it's this one. It's not that one. What do you think it is?
The middle one.
The middle one? It's not the middle one either. It's not the last one? Where did the water go? It evaporated.
Ice?
Alright, well, what you can't see is there's actually something in the bottom. It's called sodium polyacrylate, but it's just kind of like a little plastic, and it's just this white little stuff. And it's the same stuff that's actually in baby diapers. Yep, it's inside and it absorbs everything, and that's why. And if you guys want to pass this around, I guess I have a couple that you can pass around. And look and see what's in there. You can touch it, but don't eat it. Please. And what it does is it can absorb up to about 300 times as much water as its weight.
In this, I have a solution of borax, which is a special thing that's kind of soapy-ish. And in this, I will put polyvinyl alcohol, which is a polymer. I'm just going to put about 20 milliliters in here. Now I'm going to make some blue goo this time. Looks like a pretty good color, right? Alright. Now I'm going to take some of the solution from here and put it in the polyvinyl alcohol. And see, as I stir it, it starts to thicken up. It starts to get gooey a little. The more I put in, the gooier it gets. Kind of gross looking, huh? Now the reason it becomes gooey is because polyvinyl alcohol is a polymer. And what the borax does is it links the polymers and makes them stick together. See how it gets stickier? It started out as a liquid, right? And now it's a goo.
Alright, so we all know that the weatherman predicts the weather, and he can tell you kind of what it's going to be like, but he can't control it. Would you guys believe me if I said I can make snow and ice right here in this room? Believe me? Alright, let's see. This is the same stuff I just used to make the gel, but it's ground up a little bit more, so it kind of looks different when you add water to it. Just add a little bit of water. Look, it's fluffy, like snow.
Cool.
You guys want to pass this around? It feels like snow. This next one is a little bit different kind of chemical. It's called sodium acetate. It kind of smells like vinegar. It's a little gross. But right here I have a solution of it. It's dissolved in water, and there's a lot of it in the water. And I have some of it right here too. So when I add this solution that has a lot of the sodium acetate in it, when I add it with more, it's just going to be too much. And the water is going to make ice. That one works kind of good. Alright, so see, it's kind of it's not like most ice you've ever seen. It feels warm because of the reaction. Feel that? Doesn't feel like ice, does it?